Alright, in this lesson, we've finally left the world of algebra topics and we're finally into something different, which is actually the trig topics. But you know, pre-cal, the whole time you've probably been sitting here going, we're doing nothing but algebra, where's all this trig coming in? Well, we're finally hitting the trig. And in this lesson specifically, we're just laying down the foundations of trig. Y'all have done fantastic by pushing through the last bit of algebra, especially with like the logs and exponents. That stuff is never the easiest, but we finally have gotten through that, and so now we're into the trig. Okay, the first thing on trig that we learn about is how to draw in the trigonometric functions and everything. And the first thing we look at is our angles. In the world of trig, you have two types of angles. Angles being how you're rotating through a circle. Do you rotate a full circle, which is 360 degrees, or do you say a full circle is 2 pi radians? They're synonymous with each other. We're all very familiar with the degree, but we're not as quite familiar with radians, but we're going to get there. Okay, so this first example, what we want to do is just kind of get a little more familiar with how to work with the angles specifically. And in this example, part 1a, what we want to do is first of all draw 660 degrees. So when we draw an angle, we always have an xy axis, and when we start to rotate, we start on the positive x-axis. From there, since this is a 660 degrees positive, we're going to start from this x-axis and go up. If that was a negative 660, we would just go down, but we're going to go up. And remember, a full circle is 360, or each of these quadrants is divided by 9, or 90. So I'm going to start counting as I go around. So starting here, if I rotate just up, there's 90 degrees. Again, 180, 270, 360. Okay, so we're not quite yet to 660, but we're heading there. So 9, 18, 27, 36, 450 degrees would be to there, 540, 630. So right there we're at 630. We just need to go to 660. If I just need to add on 30 more degrees, which is a third of a quadrant, we're just going to go right about there. I'm going to draw that ray, and we're going to call that done. So all of this rotation is represented by our angle, which is 660 degrees. And that technically right there is drawing 660 degrees. Well, in this lesson we also learned about coterminal angles. And the difference with coterminal angles is they're all the same angles, it's just they differ by rotations, by a matter of 360 degrees or 2 pi radians. If I start at 660 degrees and I add on 360 degrees, so in other words, if I started here and went around one more full circle right back to that same ray, where would I land at? So adding these two numbers up, it would actually land us up at 1020 degrees. So alpha, since they tell us alpha needs to be a positive angle, alpha could be 1020. But look here, if I also started at 660 degrees, and let's subtract 360, we land up at 300 degrees, and since 300 is still positive, we can say alpha could also equal 300 degrees. So basically, coterminal angles, there's an infinite number of them. All you have to do is either add or subtract 360 every single time. If they come out positives, we're going to call them alphas, which is in these two cases. Okay, so let's finally get a beta. If I start here at 300 degrees and I subtract off 360 degrees, notice how it's now a negative 60 degrees. Well, since it's negative, we'll actually call this beta. And look here, if I just started here on the positive x-axis and went down to that line, wouldn't you call that down just 60 degrees? So there you go. What coterminal angles for this example is 660 is coterminal with 1020, it's coterminal with 300, and it's coterminal with negative 60. And we can keep going on this pattern for an infinite number of times if we wanted to. But you can hopefully see the picture that no matter what, whether you start at the x-axis and go down, or you start at the x-axis, rotate once, or rotate twice, or 3 times, you're always going to be landing at this same ray right here. Okay, so let's do this whole kind of concept with radians. We're going to start by drawing it. And I always go to my denominator. My denominator is a 3. That tells me what to divide my hemispheres into. So we're looking at thirds, okay? And sometimes it's easy. Let me get a different color here. Let's see about drawing this in thirds. So maybe if I did, let's see if y'all can agree with me. maybe there to, looks like if I just take out this blue line here in the middle, but that looks like 1/3, 2/3, 3/3 maybe. And then let's kind of do the bottom as well. Okay, so as I come through here to draw in this angle, we want to find 4 pi over 3. Okay, so starting here at the positive x-axis, I want to go 4/3 around. Going up to this first line is 1/3. There's 2/3, 3/3, and 4/3. So right there is where I'm going to draw my ray, and we're going to call this angle as 4 pi over 3. Okay, so if you want to see me kind of do this again one more time just real quick, is the denominator tells you how to divide your hemispheres. So I'm going to divide the top half and the lower half into 3 equal parts. So 1/3, 2/3, 3/3, and there would be 4/3. Okay, with 5/3 and 6/3 finishing up my full circle. And that right there is theta. Okay, now if we want to get, so we'll go theta equals 4 pi over 3. Okay, so now if we want to get a coterminal angle, one that's positive, it looks like I'm going to start with 4 pi over 3 and add on a full circle. A full circle is either 360 degrees, but in this case, since I have pi written, it's telling me it has to be in terms of radians. There's no degree symbol, so we're going to add on 2 pi. And we're dealing with fractions, so 4 pi over 3 plus 6 pi over 3 is 10 pi over 3. So that right there, 10 pi over 3, is coterminal with 4 pi over 3. And if you want to check it out, let's go back to the first one where you can really see the thirds. Here's 1/3, 2/3, 3, 4, 5, 6, 7, 8, 9, and 10. Look, 10 pi over 3 lands right where that initial ray was, so it checks out. Okay, and if we want to get one that's negative, I'm going to start out here with 4 pi over 3, our starting point, and I'm going to subtract 2 pi. Or 4 pi over 3 minus 6 pi over 3 is equal to negative 2 pi over 3. It is negative, so that is definitely a beta, because it tells us beta is going to be negative. And let's start here to the original problem, the one that actually have kind of the thirds drawn on it. And if we start here at the positive x-axis, and since negative, we're going to go down. There's negative 1/3, and there's negative 2/3. So it lands, again, right on that same ray. And we have two angles, 10 pi over 3 and negative 2 pi over 3, that are both coterminal with 4 pi over 3.